So here's a strong acid. This is hydrogen chloride, also known as hydrochloric acid. We start off with a lot of it, and we add it to water, and what happens? 100% of it dissociates, and we get hydronium ions and chloride ions. Water acts as a base, and all of the HCl goes to form hydronium ions and chloride ions. Okay? Why the hell? Slide sucks.
Can you repeat it one more time? Strong acids go to.
Look at this. 100% to the right. Strong acid. Strong electrolyte, right? That's why we do that. Now here's a chart. These are the 6 strong acids. There are only 6 strong acids in the world. Everybody else is a weak acid. And students often go, do I have to memorize the 6 strong acids and whether they're strong or weak? Well, it might be handy at times to know the 6 strong acids. The way to learn the 6 strong acids is look at the periodic table and look at the halogens. Hydrochloric, hydrobromic, hydroiodic. Those 3 halogens make strong acids. Hydrogen with chlorine, bromine, and iodine make strong acids. The other 3 strong acids, nitric, sulfuric, and perchloric. Okay? So there's 6 strong acids. All the other acids in the world, all the thousands and thousands of acids, are all weak. What does that mean when we say weak? It means that they're not going to fully dissociate. Only those 6 get a one-way arrow. Hydrochloric acid, you put it in solution form, all chloride ions and hydronium ions. Sulfuric acid, you put it in water, you get HSO4 minus and hydronium ions. Okay? Only those 6 are strong acids. Now, weak acids, when you put them in solution, do not form 100% products. Here we have, this is called carbonic acid, H2CO3. When it reacts with water, note that there's a 2-headed arrow on there. Okay? That 2-headed arrow implies what? Weak electrolyte, does not fully ionize. The reaction does not go all the way to completion. So look at our bar graph up there. We started with, why do they change the names on here? In this case, we could take our, I hate these slides. Okay. To keep it consistent with the reaction that's on here. Okay. If we take the H2CO3, put it in water, that's called carbonic acid. Look at what happens. Only a small amount of it goes to form HCO3 minus. A lot of it stays as H2CO3. Now the relative size of those bars can change, right, depending upon what acid you have. It might remain mostly reactants, or it might go mostly products, but the idea it doesn't form 100% products. Okay? That's what the 2-headed arrow means. Only some of it goes, not all of it. Could be 10%, could be 90%, could be anywhere in between. But not all of it goes to form products. Oops. And there's a whole list of weak acids. We're not going to spend our time worrying about naming all these and how many there are. There's lots of them. Okay? So here's our examples. And remember we talked about earlier, here we have 2 acids. Hydrochloric acid and the other one is called acetic acid. Anybody here ever drank any acetic acid? Every one of you should raise your hand. Raise your hand if you drank acetic acid. Raise your hand. You all have. You all have. Or have you tasted acetic acid before? What's acetic acid? That's the ingredient in vinegar.
Vinegar?
Vinegar is acetic acid. It's 5% acetic acid solution. Did it kill you?
No.
Huh? You might not like it, right? Some people don't like the taste of vinegar. Some people go drink it out of the bottle. I can't do that. Huh? You like it like that?
Yeah.
I've only done that once though, and it wasn't there.
I like it a salad dressing, but I can't drink it straight like that. That's kind of crazy. Why did it not kill you when you drank it? You were drinking acid.
So it's very small.
Low concentration, small concentration, only 5% acetic acid when you drink vinegar. That's a low concentration. And also, what do we know? Is that one of the strong acids, acetic acid?
No.
No, it's a weak acid. Okay? The stronger the acid, the more hydrogen ions it produces, the worse it is for you. Now, that bottle of 1 molar hydrochloric, probably wouldn't want to drink that much of that. Stomach acid is 0.1 molar hydrochloric. That's 10 times weaker than that is. Okay? Now, that 1 molar, I put my hand in that. Been there, done that. I wouldn't leave it in there, but you can put your hand in there. It doesn't do a whole lot too, because it's not also like. But I wouldn't put my hand in 1 molar nitric acid. Nitric acid burns pretty bad. Okay, so even though they're both strong acids, hydrochloric and nitric, they have different reactivities. Okay, so the weak acid, acetic acid in this case, H2 or HC2H3O2 is a weak acid, not very bad, and that's also in vinegars a low concentration. That's why you can drink it. Same reason you can eat citrus fruit. They have citric acid in them. Ooh, you're eating acid. Gonna kill you? No, because the concentration is really low and it's a weak acid. Okay, so there's two things at play there. You gotta always remember that. So when you hear the term acid, don't freak out. You gotta understand strong acid or weak acid, and what's the concentration. High concentrations are bad, right? Lots of hydrogen ions, they can burn you or damage you. So, what about bases? Bases are not quite as common in your house. The one that you probably do have a lot of is ammonia. Where do you find ammonia at your house? You might have straight ammonia. You can buy straight ammonia at a store. What do you use ammonia for? For cleaning. Why do you use ammonia? Once you use an acid, acid heats stuff up, don't they? Vinegar has acetic acid in it. So vinegar's not very good at doing one thing. Dissolving greases and oils normally. Why not? Because oils and fats and things like that are not acid soluble, they're soluble in bases. That's why ammonia-based cleaners are good at cleaning grease and things, right? That make sense? That's why when you have a clogged drain, what do you put in it? Lye or Drano. Drano is strong base because normally when you have a clogged drain, you have bacon grease down there. Bacon's good. That's why you don't pour your bacon grease down your drain, because it'll clog it, and then you gotta pour a base down there like Drano. Drano is very basic, right? Now baking soda is only slightly basic. Okay, it's a weak base. Okay. Now, strong bases are formed from group 1 and 2 metals. When you have a transition metal with hydroxide, it's normally a weak base. It doesn't fully dissociate. Okay. We're not going to worry about strengths of bases quite so much. So, I want you to tell me, strong or weak acid? Well, number one, acid or base, and then we'll talk about strong or weak. That top one.
Acid.
Why do you think it's an acid, Allison?
Because it's in the halogen area. Like
It's in a, well, and also what else do you see on the front of it?
one hydrogen.
A hydrogen atom, right? And it is one of the 6 strong acids if you look at it. One of the 6, no, you don't have your book in there, sorry. It is one of the 6 strong acids, right?
Yeah.
Okay. So that is a strong acid. All right, the second one, acid or base? The second one.
Acid.
Look at what's on the front of it there. Maggie. Look at what's on the front of it. A hydrogen. Hydrogens mean what? Acids. Acids. And it is not one of the 6 strong, so it's a weak acid. Okay? What about C?
Base.
How you know it's a base?
Because.
It has hydroxides in it, doesn't it? It's got OHs. Think it's a strong base or a weak base? It is a strong base because it's a group 1 metal. I'm not so worried about that. Okay? What about D? Acid or base?
Acid.
How do you know it's an acid? Because it has hydrogens on it like that, doesn't it? And as it turns out, that is,
Weak.
that's strong. That's sulfuric acid.
Oh.
Okay? That's one of the 6 strong acids. That's sulfuric. And then the last one. Wait, before we do the last one, I want somebody to name the last one for me. Somebody over here just rattled it off just like nobody's business. Copper, 2 hydroxide. Why do you put the 2 there?
Because of the charges.
Because it is a transition metal. Gotta have the Roman numeral there. Very good. I think y'all gonna be fine on what you say. No? That's copper 2 hydroxide. It is a base. Anytime you see the hydroxide, it's going to be a base. In this case, it's a weak base, right? Copper hydroxide is a weak base. I just do. I'm not going to ask you to know that. Okay? All right. I'm not going to worry about this either.